Okay, so good morning students. And already మనం ఇంటర్మీడియట్ సీనియర్ ఇంటర్మీడియట్ సో మనకు చాప్టర్స్ ఆల్రెడీ ఎక్స్ప్లెయిన్ చేశాను. సో ఫస్ట్ చాప్టర్ ఏంటి సార్ అంటే మనం వేవ్స్ కన్సిడర్ చేస్తున్నాం. ఓకే, సో వేవ్స్ తీసుకుంటాం. ఫస్ట్ చాప్టర్ ఈస్ వేవ్స్. సో వాట్ ఈస్ ద వేవ్స్ అండ్ సో వేవ్స్ ఉన్నటువంటి టైప్స్ కూడా మనం ఆల్రెడీ సో ఆన్లైన్ క్లాసెస్లో స్టడీ చేసాం. ఓకే, సో ఫస్ట్ ఆఫ్ ఆల్ సో వాట్ ఈస్ ద వేవ్? So wave is nothing but, so that is the energy is the transfer. So the energy is the transfer one point to another point. So without transfer matter, so the energy is transfer one place to another place. Okay, so the energy is transfer one place to another place, without, okay, so without translate medium. Okay, so without translate medium is called as a wave. Okay, so wave is nothing but tarangam, energy produce అవుతుంది, ఎనర్జీ ట్రాన్స్ఫర్ అవుతుంది ఒక పాయింట్ నుంచి అనదర్ పాయింట్ కి. సో మ్యాటర్ పదార్థం కదలకుండాని సో ఎనర్జీ అనేది ఒక పాయింట్ నుంచి అనదర్ పాయింట్ కు ట్రాన్స్లేట్ అవుతుంది. సో దట్ ఈస్ కాల్డ్ యాజ్ ఏ వేవ్స్. So waves are classified in the number of waves. So first of all, mechanical waves, and second one is non-mechanical waves. Okay, so non-mechanical waves. So non-mechanical waves is nothing but, so here, so the energy is transferred, okay, through the medium. Okay, energy is transferred through the medium. So with respect to medium is called as a mechanical waves. Here that is nothing but required medium. So required medium, so mechanical waves. So the waves is okay. Right. So the mechanical waves is nothing but, so the energy is transfer required medium. The energy is transfer required medium is called as a mechanical waves. So what is the non-mechanical waves? No required medium. So the no required medium, the energy transfer is called as a non-mechanical waves. Okay, so non-mechanical waves. So what is the mechanical waves? What is the non-mechanical waves? So mechanical waves is nothing but required medium. So non-mechanical waves is nothing but no required medium. So mechanical waves is nothing but, so that is the produced in the spring or string. Okay, so spring produce, that is producing in the string and spring. So many examples are the taken. Okay, so the non-mechanical waves is nothing but, so the light waves. Okay, so light waves is nothing but non-mechanical waves. That is nothing but heat is transferred. Okay, electromagnetic waves is also non-mechanical waves. So here taken, so the mechanical waves are classified in the two types. That is called as a first part, or the first topic is called as a, that is the transverse waves. Okay, so transverse waves. So transverse waves. So what is the transverse waves? So what is the producing the transverse waves? Just like, so here the taken here the taken string. Okay, so here the taken string. So here what is the transverse waves? What is the transverse waves? What is the longitudinous waves? So the transverse waves is nothing but here taken. So here that is called as a wave propagation. So this is called as a wave propagation in this way. So wave propagation along this way, and so the particles are vibrating along perpendicular to the wave propagation. Okay, so the particles are vibrating, so these particles are vibrating, so perpendicular to the wave propagation is called as a, what is transverse waves. So what is the transverse waves? In a wave motion, so the wave propagation, so this like, so wave propagation. Okay, clear that? Got it? So wave propagation, so perpendicular, so the particles are perpendicular or normal to the wave propagation in a wave motion is called as the transverse waves. So once again repeat. So here this called as a wave propagation. So So in this way, this called as a just like water waves or a string example are taken. So these particles are vibrating. Particles are vibrating perpendicular or normal wave propagation. Perpendicular or normal to the wave propagation is called as a transverse waves. Is called as a transverse waves. And so now in the transverse waves are producing of the peak. Okay, peak or crest and cross. Peak and crest or cross are formed alternately. Peaks or cross are formed alternately. So peak is nothing but that is also crest. Okay, peak or crest and this called as cross. So peak and cross are formed alternately along the strain. Alternately along the strain. So here taken. So what is the wavelength? So what is the wavelength is nothing but that is the distance between these two peaks, successive peaks or conjugative peaks in the same phase. Okay. So in the same phase, two conjugative peaks. So two conjugative peaks is called as a wavelength. Okay, so clear that. So what is the wavelength? So wavelength is called as the displacement, the distance. Okay, between the two conjugative peaks in a same phase is called as a wavelength. Okay, is called as a wavelength. So wavelength is denoted by the lambda. Wavelength is denoted by the lambda. And so similar pattern here also like that. The two thrusts. So the distance between the two thrusts, successive or conjugative thrusts in the same phase is also called as a wavelength. Is also called as a wavelength. And so here observing this pattern in a light waves. Okay, light waves is also transverse waves. Light waves also transverse waves. Okay, in on a water is a forming on a surface. Okay, so water waves is also transverse waves. Okay, clear that. So the transverse waves is nothing but the perpendicular count, that is the vibrating particles perpendicular to the wave propagation. Vibrating particles perpendicular to the wave propagation is called as a transverse waves. Okay, clear that. So the next one, okay, so that is called as a longitudinal waves. Okay, longitudinal waves. So what is the longitudinal waves? How to form the longitudinal waves? What is the definition of the longitudinal waves? Okay, so here observe the longitudinal waves. Okay, observe the longitudinal waves. So first of all, longitudinal waves are producing just like sound waves. Okay, in sound waves. So sound waves is nothing but, so for example, here the taken, so longitudinal waves, the spring is compared and get released to form the longitudinal waves. Longitudinal waves. Okay, so this is called as a wave propagation. So this is called as a wave propagation. So wave propagation along this way. And so the particles are vibrating parallel to the wave propagation. Particles are vibrating along the, okay, particles are vibrating parallel to the wave propagation. Parallel to the wave propagation is called longitudinal waves. Is called longitudinal waves. Just like example are the taken, the spring is pressed and get released to form the longitudinal waves. Okay, so here are taken, so this is called as a compression and this is called as a rarefaction and compression, and rarefaction are formed alternately. Okay, are formed alternately along the string. Okay, clear that? So this is called as a compression and rarefaction. Compression, rarefaction are formed alternately along this string. And so what is the wavelength? So wavelength is nothing but, so these two are compression between these two or rarefaction between these two is called as a wavelength. Is called as a wavelength. And just for example are taken, here the taken, and sound waves also longitudinal waves. Sound waves is also called as a longitudinal waves. Okay, so clear that. So what is the transverse waves and what is the longitudinal waves? So what is the transverse waves is nothing but perpendicular to the wave propagation. Here parallel to the wave propagation. Okay, perpendicular to the wave propagation and parallel to the wave propagation. So that is called the transverse waves and longitudinal waves. So best example of the transverse waves is nothing but light waves, and here also longitudinal waves is called as a sound waves. Okay. So now another topic is taken parameters. So the parameters, already we know that the parameters of wavelength, frequency. Okay. So wavelength, frequency. So first of all, and that is called as the first parameter. Parameters. So first parameter is called as a wavelength, and second is called as a amplitude, and so third one is called as a wavelength, amplitude, frequency are taken, and so wavelength it is denoted by the lambda. Wavelength it is denoted by the lambda, and amplitude is denoted by the small a letter. Okay, clear that? So and another taken frequency. So frequency it is denoted by the nu or n. Okay, nu or small letter n denoted by. Okay, so next fourth one also phase vibration. So phase vibration it is denoted by the pi. Okay, it is denoted by the pi. So what is the wavelength? So wavelength is nothing but, already we know that the wavelength is nothing but, so the distance between the two successive peaks. The distance between the two successive peaks is called as a wavelength. Okay, so it is denoted by the lambda. Okay, two successive peaks, the displacement or the distance between the two successive peaks or two consecutive peaks is called as a wavelength. It is denoted by the lambda. And so what is the amplitude? So amplitude is nothing but, so the displacement or to producing the mean position. Maximum displacement, maximum distance produced, okay, produced or to the mean position in a wave motion. Mean position in a wave motion is called as a amplitude. Now to see here, this is called as a amplitude. Here also amplitude. Amplitude is nothing but, so maximum displacement from its mean position. Maximum displacement from its mean position is called as a amplitude. Okay. So amplitude it is denoted by the small a letter. Okay, got it. So now next one is frequency. So what is the frequency? So the frequency is nothing but number of vibrations for 1 second. Okay, number of vibrations for 1 second is called as a frequency. So number of vibrations for 1 second is called as a frequency. So if in case of, so the pan is vibrating, the cell is vibrating for 1 second, so the pan is rotating. So the number of turns in 1 second, the pan is rotating, the number of turns in 1 second is called as a frequency of the fan. Okay, frequency of the fan. So the cell is vibrating, so number of turns in 1 second is called as also frequency. Okay, so frequency it is denoted by the nu or n. Frequency it is denoted by the nu or n. Okay, so the phase of vibration. So the phase of vibration is gives the at any instant of time. Okay, so that is the position. Okay, that is the position and direction. Okay, so the phase of the vibration is give at any instant, at any time. So the position and direction, it is denoted by the pi. Okay, so once again repeat these parameters. Okay, in the intermediate level, so very important. So what is the wavelength? So wavelength is nothing but the successive. Okay, the successive is conjugate to peaks. The distance is called as a wavelength. The distance or displacement between the two successive, okay, two successive crest is called as a wavelength. And so now another parameter is taken, amplitude. So what is the amplitude? Amplitude is nothing but, so the maximum displacement from its mean position, maximum displacement from its mean position is called as the amplitude. And so now another parameter is taken, that is the frequency. So what is the frequency? So frequency is nothing but, so the number of vibrations for 1 second is called as the frequency. Number of vibrations for 1 second is called as a frequency, and it is denoted by the nu letter or n. Okay, so clear that. So now another pattern is taken, another parameter is taken, that is the phase vibration. Okay, so what is the phase vibration? So the phase vibration of the vibrating particle, phase vibration of the vibrating particle at any instant is gives to position and direction, regard. Okay, position and direction regard at any instant is called as a phase vibration, and phase vibration, it is denoted by the pi letter. Okay, phase vibration, it is denoted by the pi letter. Okay, clear. So now next one, discuss the topic is, so that is called as a stationary waves. Already we know that the stationary waves. Okay, stationary waves or standing waves. Okay, stationary waves and standing waves. So most important topic in your waves chapter. So standing waves. So standing waves, this example of the taken in the diagram. So here observe. So first of all, to form the stationary waves, just like to here observe. So this pattern here observe. So first of all, so the wave translation, just like this called as the displacement y1 and displacement y2. Okay. Now, so this here, the string is fixed. The string is fixed between the two ends. The string is fixed between the two ends and plugged at midpoint. Okay, so the string is fixed at two ends. Okay, the string is fixed between the two ends of the wire, and it is plugged at midpoint. So these waves are formed along just like. Okay, here this is called as the same amplitude, same frequency, same wavelength. Okay, so wavelength, amplitude, frequency. Okay, so and traveling in opposite direction. These two waves have same amplitude, same frequency, same wavelength, and traveling in opposite direction. And superimposed or overlapping to each other. So these points are overlapping to each other. So these waves are formed is called as these light waves is called as stationary waves. Okay, so what is that? Stationary waves are formed along the string. So what is the stationary waves? So stationary waves and standing waves. Okay, so here this wire is fixed or string is fixed between the two ends. String is fixed between the two ends of the wire, and it is plugged at midpoint of the wire on the wire. Okay, midpoint on the wire, and so waves are formed just like. So waves are, this called as instant wave and reflected wave. Those waves have the same amplitude, same frequency, same wavelength. Okay, same amplitude, same frequency, same wavelength, and so overlapping to each other is producing of the stationary waves along the length of the string. Stationary waves are producing along the length of the string. Okay, clear that. So first of all, so general point are observed. So this is called as a wave, complete wave cycle or complete wave is formed. Okay, now complete wave is formed. So this is called as a two peaks are formed is called as the wavelength. Already we know that. Okay, already studied. Okay, so what is the wavelength? So wavelength is nothing but, so the distance between the two conjugative peaks. to conjugate to fix is called as the wavelength. And that means simply, so that cycle total cycle is called as a wavelength. Half of the is called as a half wavelength, and another half taken is lambda by 4. Okay, total one cycle is completed is called as a completed wavelength, lambda 1 lambda. Okay, so half of the cycle is taken lambda by 2. Another half taken is lambda by 4. Okay, here observe. So this called as a positions x is equal to 0. Okay, so x is equal to 0. Here the taken, that is called as a lambda by 4. And here the taken lambda by 2. Here the taken 3 lambda by 2. Here the taken, so 2 lambda by 2. So etc. taken. So the complete one cycle. So complete one cycle is formed, taken wavelength. So that is the lambda. Half of the wavelength is lambda by 2. Another half taken is lambda by 4. So here observe these positions. X is equal to 0 and lambda by 4, lambda by 2, 3 lambda by 2, 2 lambda by 2, etc. are taken. Okay. So now here observe. So this called as a nodes, and here also antinodes and nodes. So what is the node? What is the antinode? Okay, what is the node and what is the antinode? So the maximum amplitude from its position, okay, maximum amplitude from its mean position is called as a antinodes. So from its mean position is called as a antinode. Okay, so these points is called as a antinodes. So antinodes is nothing but here the taken lambda by 4, 3 lambda by 4, okay, 3 lambda by 4, 2 lambda by 2, sorry, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, etc. are taken. So those positions are is called as a antinodes. Okay, those positions are is called as a antinodes. So these are. And so another is taken nodes. So what is the nodes? So nodes is nothing but 0, lambda by 2, 2 lambda by 2, so etc. are taken. So position, those positions is called as a nodes. Okay, so position is, that is a 0, or displacement is 0. So this position is taken nodes. What is the antinode? What is the node? So node is nothing but position is 0. Okay, na? Position is minimum or position is 0 is called as a node. Here observe in the diagram, so 0, lambda by 2, 2 lambda by 2, etc. position are called as a nodes. And so what is the antinodes? Antinodes is nothing but, so that is the maximum amplitude or maximum displacement from its mean position is called as a antinodes. Okay, clear that. What is the nodes? What is the antinodes? So antinode and nodes are formed along the length of the string. Antinodes and nodes are formed along the length of the string. And so what is the antinodes? What is the antinodes is nothing but, so the maximum length from its mean position is called as a antinodes. And so here position is 0. That is nothing but amplitude is 0 is called as a nodes. And so the length of the string are taken is L. The length of the string is taken L. And so now we have taken this called as one loop, and this called as another loop, and this called as third loop. So the number of the loops are formed. So how many loops are formed? So no idea. That is nothing but taken is P, and the length of the string is taken L. So number of the loops is taken is P, and length of the string is L, and each length of the segment, each length of the loop. So this is called as a loop. Okay, this is another loop. And so length of the each loop is L by P. So the length of the each loop, each segment is L by P, and which is equal to lambda by 2, So this is called as a half of the wavelength. So L by P is equal to lambda by 2, and these are lengths. So this is called as a length of the string segment, and this is called as a half of the wavelength. Okay, clear that. Okay, and so now discuss the another topic is the next class. Okay, thanks friends.